I think we will start. Kannst du mal umblättern?
Ach, den hier. Das?
Ja, okay.
Ich auch noch Papierhalter, ja.
Thank you. And can you please put the chair beside?
Ich verstehe zwar ein wenig Englisch.
Thank you.
Ja, schaffe ich auch.
Thank you very much. So, until lunch. Or what? Do you come with us to lunch?
Na klar.
Okay. I think we will continue.
Yeah.
If you have all calculated the values A to C, we will put it together like this. Where is it? I think we begin the thinking from Paul again. We have to put G A C N G A C 1 divided by times. Then we have to make a sum of all this here.
Yeah.
And what is the same? We can look for the same that we not have to make too many to do here. The same is A3, 4, A3, 3, 4 is this one. This is equal.
Yeah.
And I think this is equal to A3, C3, A3, 3. Is this one?
Yeah.
Is equal with A4, C4. That's equal? More equal?
Yeah.
3 and 4. I think all the others are equal. All the others are equal. C1 to A4 to A3. C1 to A3, A4 is the same as A2. Okay. And all these ones are equal. So we have that word. So we have ln G A2 C1 multiplied by what?
600.
Okay. Then we have ln G A2 C3 times 0.6 times and what we do
Times 4 times.
4 times plus and now we have 2 times
Yeah.
and then GA3 C3 times
1.25.
n times 2 and then GA4. Now we have A3 CC and we have this one A4 C3 times and bracket close. That's the situation for this. And you can also make such a it's not practicable, but yesterday we told this is not made everywhere in the world, but if you try, you can use the program for it. So, you can also calculate the GMR of AA. Then you have, that's not in the book in it. If you have A3, A2, A4, and you want to calculate the safe, you can use a formula. Where is the formula? The formula is in chapter 3. You can use this formula. You have to put in this. You can calculate it about this. But you can calculate it in the same way as here. That you say A3, A2, A4. You have you can calculate A3, A3. How? Not here. A3, A3. You can use this formula. You can ln G A3, A3. I have to build here the ln, and then is minus 1.5 and then A3, and the length of A3 was my book. Yeah. This was 250. 250 and then 0 point. Then you will get the same from A3 to A3. Then you can get ln GA2 to A2 is minus plus, I have to say it, 1.5 plus ln. Okay, that's on itself. And that is ln G A4, A4.
Yeah.
So, now I have the self of the, and then I have to calculate A3 to A2, ln G A3 to A2 is what do we need here? A3, A2. This one? Huh? We do have it. A3, A2. Is this one?
Yeah.
The below formula. We can use this formula and have this formula to put in here, and have to create this. We use this formula A2, A3, and we have ln A3, A4. How to calculate this? This one? Yeah, it's this one. We can use this formula.
Yeah.
This formula, and then we have this value. And then we have all values we can put in. Can put in for this, for C, we can put in here A. I think it's the same length. And we have to put in for all things here A. And then AA. That's another possibility. It must be, it will be the same result. But if you use a computer, you can do it and put the value to zero. One value to zero. You have to be attention that you don't divide by zero, but I think it's easier for this one to use this formula. But you can do it. It was only a training for you that you haven't we repeated this, and then we will you can calculate this. So chapter 5. Back to chapter 5. So now we have calculated all the G's, and now it's not new to calculate all the reactances, and then the reactances between the phases, and then the phase reactances as result. That's always the same. So, what we not discussed is with the electrode arms. Now the electrode arms all work in one. If have had all the same lengths, then maybe that one it's impractical. The phases are different now. What to do then? Here are the electrodes, and here are flexible cables. And what to do then? We have discussed until to this, but we have to go to chapter 2. I think we have then to, up to now we have to use this formula. Then we have to use this formula. If they're not in the same, now they have the same length, and they were in this. They have been in the same plane here in the start. And if they become longer, then you have to use this formula. But it's so complicated that I not use in the book here. I think there's only one example where this is used for this additional reactor, because they are not. It's not possible to have here the same length and the conductor is not a loop. This is an additional reactor, and then we will discuss later this example. So now back to chapter 5. I think we discussed this example, and now the middle phase is higher. What to do now? It's the same calculation or it's a different calculation? What's the difference between this example and the example? Example 5.7. Example 5.8. We need 6 values. XAA. We calculate it. We can take over or we can't take over. Is the same or is different?
Same.
This is same. XBB, same or different?
Same.
Same. XCC, same. CC. XAB, GAB, different.
Yeah.
Yes. But it's the same as XBC.
Yes.
What is about GAC?
It's same.
This is same. That means we only in this example have to calculate new XAB.
Yes.
AB. So, we have to say what it is. Number. A3, A2, A4, B1, B2. What is new? Something new? Or something not new? I think if we have here A2, then we have here B1 and B2, yeah. And then this is where I've already done here. I don't think we will now here, we have to look at chapter 3,
Yeah.
chapter 3, which says we to use this one. We have to put in this formula we already discussed. I don't know if you have problems to use this formula. You have to calculate by yourself. But if we make this examples by yourself, if I would do it, it would also take a long time to calculate this minimum. Therefore, we have a program, but you want to learn. So we have to calculate twice. One times for B1 and one times for B3. So that when we have discussed this one, this one, or then the second time we have what do we have? we can do A3 to B1. we have to look where it is. Yeah, that's in this direction. We have to use the above formula, but we can make it in this way. B1 and A3 is the same. Therefore, I said yes. But so, and this formula we already used. This formula we already used, and then we have the same as last time with different values. But they are not, they are no equal now. B1 to A3 is different to B1 A4. You have to calculate 6 different values. And here. We have to make a table.
Yeah.
It's clear, or should I explain? Maybe like. What was the last? I don't know where's left. Or yeah, I think it's this, but we no, it was on the it was on the ladder. This was the sleep. I think was this together with this. This together with this. Now we have this situation. I think we go to chapter 5. Chapter 5. That's not chapter 5.
Yeah.
That's here. the file. So, now we have calculated
Yes.
this values,
Yes.
and now we have to, that's not equal,
Yes.
so we have to delete, and so we have A3B1, then we have to put in A4B1
Yeah.
times, and we have had A3B2, we have to use this one, A4B2. And then we have calculated this value. And then we can do the same what we have done the examples before. The 6 examples before. Oh. I think the result is not here. The results will be look in the book. It is example 5a. Well, you can see what a work it is if you do it manually. So it should be triangulated here. And triangulated means it should be the same value ABC. What do we get? What do we get? Not triangulated, not symmetrical, but nearly symmetrical. I think it's 5% not symmetrical. But it's nearly symmetrical. But it's, you can use the program and change the position of the electrode arm, and then you can see what happens. So, I think we will finish today. Then we have time for many discussions and questions for you. We are now at 5.9. The electrodes. But I think that is the position in a furnace what is triangulated. So we can use a simpler formula. So, what have we to do for the electrodes? What have we to do? These are the 3 electrodes, and we want to calculate the reactance of the electrodes.
Yes.
So,
First, we have to calculate the GMI.
What?
We have to calculate the GMI.
the chin. What? Schema?
GMR.
GMR, yes. Yes. Can you say how GAB is what?
GBC. Is A.
BC is CA
A.
is A.
Yeah.
Is 1.1 meters.
Yeah.
Well, that was easy.
Yes.
Easy. What do we have to do with? And now we have to calculate GAA.
Yes.
It's GBB.
Yes.
It's GCC. Which formula we use? Formulas in chapter 2. Well, this formula we can't use. We have round lighter, round conductors. Round conductors we have here. Or this one.
No.
This is Mutsche and this is Cell. The side is here.
Yeah. Yes.
The side is here. Which formula we use?
Left, middle. Left.
This one?
No.
This one?
Yeah.
This one.
Yeah.
But we have only the outside radius.
We can calculate the skin depths.
Yes. Yeah. But I don't want to say it, but you have to you have to say it. We have to calculate the skin depth. The skin depth is always the same, but with the next value. We have 12.8. 5.9, I think. 5.9. I think this is exercise. And I think the skin depth in this place is 159 millimeters. Okay. What we put in this formula? R2 is, we go back to
300.
to chapter 5. I think you have already said the correct answer is 300 millimeters.
Yeah.
And what is R1?
Is 141.
300 millimeters
Minus
159 millimeters. R1 is
140.
41 millimeters. Oh, okay. And then we use the formula which we discussed, and then we can calculate GA. And it's the same as PB and CC. And then it's the same. Then it's the same as before. If you have to, the most important thing for reactance calculation is to calculate G. And if you have the G, is always the same. And if we show the result of, you see, this is only 1.5 page. The last example is boom.
This is
So we get one, because it's a full symmetrical case, we get only one value. It's the same for A, B, and C. So, additional electrode. We only use two more examples. We have time enough to discuss another. So I think it's a complete other example. We don't need something from here, from the old examples. Yeah. What to do now? The solution is given here, but I think I will put it away.
First we had to calculate the G.
The G of what?
G.
How many conductors we have?
4.
1, 2, 3, 4. 4 conductors.
Yes.
We have to calculate the G of the conductor itself and of the conductor. No, I will paint it.
Lady 4.
Paint it here. The conductors are named in 1,
Next
2, 3, 4.
Yeah.
Now I will begin with the last one. What do we have to calculate? We have to calculate the 4 conductors. 4 conductors. X11, X12, X13, X14, X2, X3, X4, X2, X3, X4, X2, X3, X4, X2, X3, X4,
Yeah.
and then here always the 1, here always the 2, here always the 3, here always the 4. So, the program is stupid. Calculates all values. Do we have to calculate all values? Why not?
This reactance is for 4.
950. Yeah, in this special case it's the same, yes? In this special, because they are the same length, it's the same diameter and it's the same form. Yeah? Then we have to say one is for 4. One is for 4. 2 is
3.
2 is 3.
Yeah.
So, more.
Okay. 1, 2, 2, 1, 3, 3, 1.
1 to 2 is 2 to
1, 2 is 2.
1. I have to look here.
1, 2, 2, 1. You see?
This is the same, yes. But what is the value of 1, 2?
Okay.
How to calculate?
X 1, 2 is same as X 3, 4.
This is correct.
Yeah.
We will look in chapter 2, where the reactance is. We go to chapter 2. Chapter 2. Over here. Where is it?
Okay.
Huh?
I.
What? Remember yesterday?
Okay. This is general. Okay. Okay. So 1, 2 is 0.
Okay.
Yes.
It's 0. I will. 1,
Okay.
2 is 0. 2, 1 is 0.
Yes.
All which are 10 to
2, 3, 0.
2, 3,
3, 2.
is 0.
3, 4.
Is 0.
4, 3.
4, 3 is
Yes.
okay. 1, 2, 3 we have. 1, 2, 3 we have. But,
Oh, 1, 4 is 0.
Yeah.
0, 0.
so,
Yes.
3, 1, 2, 1. Yeah.
Same.
Uh, 3, 1 is 2, 4. In this we go back to chapter 5 and we can see it. So in this special case, because we have here 2,500 and we have 1,250 millimeters, and we have also here 950 millimeters, and here 950 millimeters. I made it since the calculation is not so much. And so we have 3, 1 is the same as 2, 4.
Yeah.
I think I have to mark it with another color. I think that takes the 3, 1, 3 is always the same as this one, and then we all this one and this one is also the same.
Yes.
So
We have to select 1, 2, 3.
3 values. For this special case, if you make it longer, you have to calculate some values more. So, and how do you get? Now we have part reactances. We want to have x, the whole x.
Yes. Times
2 times
4. 4?
Yeah.
2 times 4.
which one? 2 times? It's good.
Oh, okay. 2 times x11.
x11 is the same as x44. Okay. x11
Plus
plus
2 times x22.
x22.
2 and minus
Minus, yes, it's correct.
4. 1, 2, 3, 4. 4 times x equals 3. Yeah.
The problem is now how to calculate x11 and x22 is clear.
Yes.
You have to for x11 you have to calculate G out of, that's always the same, 150 millimeters, and the inside radius is 140.5 millimeters with skin depth. And then you from that one to the G11, and out of G11
Yes.
that is 11x. The G12 is the same,
Yeah.
but it's a different
Yes.
x22. So that was the easiest of this. Now we have calculate this to this. We have here a G13. No. We have to look which formula. Which formula is it? I think it's in chapter 2. So we have to use it. This here.
Yes.
That's also. And what we have to, we have G13 is here named G12. How big is it? Yes. Okay, this one. So, what have we to do? We have the values L1. This is L1 is
1.5.
Yeah, 1.25 meters.
Yes.
L2 is
0.9.
5 meters. So, and we have to say set 1 0, set 2 0 is, in this special case,
Zero.
0. Both are 0. It's the best I start the coordinate system set in this direction. Okay. And then I have to look what to do. We have, what are we to do? We have to calculate 4 times the function. We have to calculate how 1, 2, 3, and 4. We have 2 divided by Z13.
Yeah.
Zero.
No.
No.
It is just
My fault. my fault. Then I have to put in 1.25 here. And that's my fault. That was
0.3.
0.3.
Yeah.
Better. 0.3 divided by
Yes, so the result is 0.24. Yeah.
V2 is L2 minus 0 divided by 0.3 is 2 divided by you don't need a calculator. It's 1.
Yes.
Ah, I always do my mistakes today.
The result is 0.76. Yes.
I hope I make for 3 correct. It's 0 minus L1 is minus L1. L1 I have to look 1.5 minus 1.
Yeah.
V4 is 0 minus 0 divided is 0.
Yeah.
So, and now we have this values, and we can put in x1, 2 is minus 0.5 times 1.257 exponent minus 6 per meter, and we have 50 cycles. Seconds walk minus 1 times F1 minus F6 minus 3 is minus 1 and plus 0. So, and now we have x1, 2.
We have G1.
Yes. And G1 was at 1.15 meters.
Okay.
So, control of meters against meters. Okay. Seconds with seconds.
Okay.
Watt per ampere. Per ampere.
Yes.
Divided by ampere is all. It's correct. So, and then you have to put in this formula.
Yeah.
And you have to calculate 4 times. It's a problem with 0. No. If V is 0, we have to calculate 0. That's 1 minus 1. That's not good for what I did. If V is 0, you have to make a limit. That's not done here. I think that there will become a 0 out of this, but it's a problem. I will look from my computer out for this example. It's example number 11. Or what is that? 10. 10.
Yeah.
10. 8. 8. I have to put in here all the input values, and then here this values we have just calculated, and that is the function values we get out. And if you put in the 0, you will get in the -1. But yes, you can try and then -1.
Yeah.
I think I will tell you tomorrow. We come back to this problem. I can't say it. I haven't done it by manual. I haven't done it by program. But I think it must be in this. Which page?
100.
100. This is done here. As it is x 1, 2. No, it's not x12, it's x13. It's x13. Where is calculated x13? Yes, it is. It's -1, 0. Yeah, it's correct. It's correct. I make the mistake. If you look at this one and you put in 0, you can see what happens. If you put in 0, you will get here 0, here 0.
Yes.
Log from 1 is 0, times 0 is 0.
Yeah.
And you will get here 0, and then you will only get the root of 1, and it's only -1. That's no problem.
Yeah.
So and then we have calculated 1, 2, 3. That was new. All other values we have already discussed another way. That is the first time we used this formula, but it's more complicated than other formulas. So, and then we get, if we put, now we have 1, 3, and then we can put in this 1, 3, and all others we have already discussed how, and then we will get the reactants of this. I think we have the same here.
Yes.
So. Okay. I think now then there's an exercise for you, and then that's really the last example. We are already almost finished with the example, with an important example. But I think this example we will discuss after lunch.
Okay.
Do you have questions to the end? Or we will, after lunch we will discuss if you have questions, and then we will make, I think you should calculate this by yourselves. It's not so much, it takes half an hour, but if you come here to the correct result, you understand a lot. Okay. I think I will put